Right, for this section then we're going to have a look at radioactivity and what it actually means. Now first of all, if you think back about all of the materials around us, and everything is made up of atoms, and there are billions and billions of them in just one single tiny drop of water. So each atom has a tiny central nucleus made of protons and neutrons, as you know, and there are electrons orbiting around it. Thankfully, the nuclei found in most atoms are perfectly stable. The nucleus in a small number of atoms is unstable, and radioactive decay occurs when this nucleus breaks down and emits one of the three types of ionizing radiation. All forms of ionizing radiation come from the nucleus of unstable atoms, but the three types are all very different. Alpha particles, for instance, these are very ionizing particles made up of 2 protons and 2 neutrons. So this is the same as a helium nucleus. Okay, so please make sure you don't say a helium atom, because that has electrons. We are just talking about a helium nucleus made of 2 protons and 2 neutrons. If we're looking at a beta particle is a fast electron from the nucleus, and beta particles have a negative charge. We'll just go back. Alpha particles have a positive charge. And the third type of radiation is something called gamma rays. A gamma ray is a high frequency electromagnetic wave, and you might remember that from P1 when you were looking at the electromagnetic spectrum. This kind of radiation is not very ionizing, but travels very far and is very penetrating. Okay, so this sort of summarises what I've just said. Alpha is a helium nucleus, beta is an electron, and gamma is a high frequency wave. Okay, so if we look at what ionizing radiation is, alpha particles, beta particles and gamma rays are all described as ionizing radiations, and we've talked about ions and ionization quite a lot. They ionize the atoms of any material they pass through. Atoms are usually neutral. They have no charge because the number of positive protons is the same as the number of negative electrons. So because they are equally balanced, there is no charge. When an atom gains or loses an electron, it becomes charged, as the charges are no longer balanced. So if you remember, we said that if it gains an electron, it becomes negative, and if it loses an electron, it becomes positive, and the atom is now called an ion. When ionizing radiation passes through a spark chamber, it ionizes the gas inside by removing some electrons from the atoms, and this causes an electric current which is seen as a spark between metal plates. Both alpha and beta particles have a charge, as I said. When they pass close to atoms, they either attract or repel electrons away from the atom, so they actually cause ionization. Alpha particles have a greater mass and greater charge. This makes them the most ionizing form of radiation. Okay, so if we have a look then at how we actually work out the radioactive decay of different substances. So a substance that contains radioactive atoms gives out radiation all of the time. The nuclei within it decays. As you know, the number of these decays per second is called the activity. In a radioactive substance, atoms are decaying all of the time, and as time passes the activity gradually decreases, and an example can be seen if you look in your revision guide. So when we look at the the decay, we talk about it in half-life. As the radioactive atoms within the substance decay, fewer and fewer radioactive nuclei remain, and this leads to a drop in activity as time passes. The time taken for half of the radioactive nuclei in a sample to decay is called its half-life, and this is the time it takes for the activity to halve. In each half-life, the number of radioactive atoms remaining halves. So if you had 400 atoms to start with, after one half-life you will have 200 left. After a second half-life you will have 100, then 50, and so on. Don't be tempted to start off with 400 and then it says how many is left after 4 half-lives and just dividing it by 4, because that's not right. You have to half it 4 times. So 200, 100, 50, 25. You can see the answer would be completely different. So if you have a look then, this is a typical half-life decay curve, and they always look like this. They always have this shape. Now if you're asked to work out the half-life of a radioactive substance, the question might say, how long does it take for one half-life, for instance? So if you've got 80 counts, you would half that to 40. You would follow that along until you hit the curve, and then you would go down to the time. So if I'm looking at that, it's around about 2 minutes. If you're asked to work out how much is left after 2 half-lives, you would go from 80 down to 40, that's 1 half-life, then down to 20, that's 2 half-lives, follow it along until you hit the curve, and then go down. So that would probably be about, looks like about 4 minutes, and so on. Please make sure you think about that very carefully and look at the units on the graph.